We're going to take a look at rationalizing radical expressions. Rationalizing a radical expression means to remove the radical sign from the denominator. To be in simplest form, we cannot have any radical expressions in the denominator. So a simple example of that might be something like this. Square root of 36a over 4a to the third. So to rewrite this, we have 36a as a radicand in my numerator, and then we have square root of 4a to the third in my denominator. This is one way to take a look at it. I see in the numerator, I see a perfect square factor of 36, and then I have square root of a, which cannot get simplified any further. In the denominator, I see perfect square factors 4a squared and then square root of a. I can't do anything further with that. So this becomes square root of 36 is 9, or I'm sorry, 6 radical a in the numerator, and then square root of 4a squared becomes 2a and radical a. We can simplify that further because anything divided by itself is 1. So radical a divided by radical a is 1. We can simplify 6 divided by 2. They have a common factor of 2, so 6 divided by 2 is 3. 2 divided by 2 is 1. So my final answer becomes 3 over a. Another example of simplifying with radicals in the denominator. This one actually needs to get rationalized by multiplying by a, we've called them FFUs, funny forms of 1. So for example, radical 2 over radical 3. I can't do any simplifying with either the numerator or the denominator, so I'm going to go ahead and multiply by 1, but that 1 is going to be in the form of radical 3 over radical 3. I do that because when I multiply radical 3 times radical 3 in the denominator, I get a perfect square underneath the radical sign. So I now have radical 6 over 3. I've removed any radical expressions from the denominator. So that is now simplest form. When we simplify radical expressions that have a sum or difference in the denominator, we need to use what we call conjugates. Conjugates are sums and differences of the same two terms. So for example, radical 2 plus radical 3 and radical 2 minus radical 3 are conjugates. And if we FOIL conjugates, we end up removing radical expressions. So this becomes a very important tool in rationalizing. Let's first go through an example of FOILing conjugates so that you understand how radicals end up being removed. So if I have the conjugates that we just looked at, radical 2 plus radical 3, radical 2 minus radical 3. If I perform FOIL, I see that radical 2 times radical 2, my first terms, is square root of 4. Plus then my outer terms becomes the product negative radical 6. My inner terms becomes the product positive radical 6. And my last terms is the product negative radical 9. And so what you'll see is the product of my first terms and the product of my last terms both end up being perfect squares. So that's going to remove those radicals. And then my middle two terms, the products of my outer terms and the products of my inner terms, are opposites. So those are going to go to 0. Square root of 4 is 2. Square root of 9 is 3, so I have a negative 3. So now I can combine all those terms. I get 2 plus 0 minus 3, which is a negative 1. So by multiplying conjugates, I've removed all radical expressions. Let's take a look at how this helps us rationalize a radical expression with a sum in the denominator. If I ask you to simplify negative 3 over radical 10 plus radical 5, I'm going to multiply by a form of 1, and that form of 1 is going to use the conjugate of the denominator. So I'm going to multiply numerator by 10 negative radical 10 minus radical 5, and then the denominator by that same thing, radical 10 minus radical 5. My first part of simplifying, then, I need to distribute the negative 3 in the numerator. So my numerator becomes negative 3 radical 10 plus 3 radical 5. I have a negative times a negative, so I now have a positive expression here. If I use FOIL on my denominator, radical 10 plus radical 5 times radical 10 minus radical 5, we're going to find that all of our radical signs disappear from the denominator. So let's go ahead and do that. I'm going to carry the numerator down as is. And if I look at FOIL, radical 10 times radical 10, that's square root of 100. My outer terms, radical 10 times negative radical 5, that becomes a negative radical 50. My inner product is a positive radical 50. And then my last becomes a negative radical 25. So you see, just as in our last example, these are perfect squares, and then these terms are opposites, meaning they're going to end up canceling each other out. So if I simplify, one more step here, negative 3 radical 10 plus 3 radical 5 over square root of 100 is 10, minus square root of 25 is 5. So you see that done my job. I rationalized. I removed all radical expressions from the denominator.